Here's a formula for constructing a confidence interval for an unknown population proportion. The statistic and unbiased point estimator is the sample proportion p hat. The margin of error is how much sampling error is expected. Sampling error is the inaccuracy of any one sample statistic due to random chance. How much random chance fluctuation should occur? This is what a margin of error tells us. We expect some error in our point estimator, in our sample proportion, because 95% of sample proportions should be as much as 1.96 standard deviations away from the true population proportion. Let's relate this to what we've probably seen before. Preceding an election, various news outlets and polling agencies are taking samples and reporting things like, a recent poll shows candidate A with 51% of the vote leading into next week's election. The poll has a margin of error of plus or minus 4%. We should already have a grasp on what all this implies. First, the sample proportion was 0.51. This is the point estimate of the true proportion of the electorate who would vote for candidate A if the election were held today. And the 1.96 standard deviation for the margin of error, the margin of sampling error, would allow us to use some algebra to determine the sample size. In this case, it must have been a sample of 600. So let's do a write-up of the confidence interval as if we were the data scientists who took the sample. We're collecting a 95% confidence interval for the proportion of voters who plan to vote for candidate A. Our sample size is 600. N times P and N times 1 minus P are sufficiently large to ensure a sampling distribution that is approximately normal. In fact, we had 306 successes and 294 failures in our sample. We took a random sample of over 600 voters, so randomness is okay, and the population is very large. Perhaps it's a congressional race with several thousand voters in the district. P hat is 0.51. We add and subtract the margin of error, which quantifies the amount of sampling error expected. Thus, our confidence interval is 0.47 to 0.55. We're 95% confident that the actual proportion of voters currently planning on voting for candidate A is between 47 and 55%. Assuming there's only one other candidate, this implies that the race is too close to call. There exists the chance that candidate A actually has less than 50% of the vote. Like we did with a z-interval of means, let's visualize how this could happen. Our point estimator was 0.51 and we added and subtracted the margin of error. If our sample proportion is very close to the true proportion like this, then the population proportion is above 50%, and right now at least, candidate A would win the election. But understanding margin of error and the sampling error it is based upon, there exists the chance that our point estimator of 0.51 lies up here further to the right. In instances such as these, the true proportion is closer to 48%. Candidate A would actually lose if the election was held today.